Today's lesson is lesson 5.3, Formulating Quadratic Functions from Roots. Remember that a quadratic function is a function that can be written in the form f of x equals ax squared plus bx plus c. And a quadratic equation, let me go ahead and change that. That should say a quadratic equation. There we go, is an equation that can be written in the form ax squared plus bx plus c is equal to 0. Notice in these two forms, the only difference is our equal part. In the first one, the function, we're ready to go ahead and graph. F of x, remember, is y equals. And so we're just ready to go ahead and put that into a graphing technology, and we can go ahead and see what the graph looks like. In the equation form, when we're equal to 0, we're setting up ready to find our roots. The graph of f of x equals x squared plus 4x is shown. The x-intercept, zeros, solutions, roots, factors of this quadratic function are related. For this function, the x-intercepts of this function are located at -4, 0, and 0, 0. The x-intercepts are the coordinate points where the graph intersects the x-axis. The zeros of the function f of x equals x squared plus 4x are set at -4 and 0. The zeros are the x values of the x-intercepts, or the x values where f of x is equal to 0. This part right here is just referring to we can substitute 0 in for our x's, and we can solve algebraically. The linear factors of the function f of x equals x squared plus 4x are x and x plus 4. What they've gone ahead and done is they've taken this part right here and they factored it. What we can multiply. If we take x and x plus 4 and we multiply them together by distributing, we get x squared plus 4x. Let me squeeze it on the screen. There we go. The solutions of our equation x squared plus 4x equals 0 are -4 and 0. So we could solve it, and these are the two answers that we can get. Yes, we would get two answers. The solutions are the x values where f of x equals 0. Notice right here that we have the solutions are the x values where f of x equals 0. Notice we also said that the zeros are where the x values from f of x equals 0. So solution is now just another word for 0, which remember is just our x values of our x-intercepts. So we can find our solutions simply by finding our x-intercept. The roots of the function of the equation x squared plus 4x equals 0 are -4 and 0. The quadratic equation is another name for the solution. A root of a quadratic equation is another name for the solution. So notice all these words that we're seeing here mean the same thing. So I can come in with my highlighter and I can call it the x-intercepts. I could call it the zeros. I could call it the solutions, or I could call it the roots. They all mean the same thing. They all mean that if we have access to that graphing technology, we can go to our graph and we can find these points right here. Maybe let me make that a little bit bigger. These points are right here where our graph is touching the x-axis, and we can find all of those. This is going to allow us to graph. This is going to allow us to write the equation, to solve all these things. All right, let's go ahead and take a look at example 1. The graph of f of x equals x squared plus 4x minus 12 is shown. Use the graph to identify the x-intercepts, zeros, and linear factors of the function in the solutions and roots of its graphed equation. All right, so first they're going to ask us for the x-intercepts. All we have to do is go to our graph and find where the graph is touching the x-axis. There's the first point right there. And there's the second point right there. So we're going to go ahead and say that the first one is at -6, 0, because remember, an x-intercept should be an ordered pair. And the second one appears to be at 2, 0. All right, so just remember, intercepts need to be ordered pairs, and you're normally going to see them as the x value that where the graph is touching the x-axis, comma 0, because we're not going to move up or down off of the x-axis. Now we're going to come in and we're going to change it to the zeros. Well, remember, we've already talked about this. The zeros are the x values of our x-intercepts, so -6 and +2. You could put an and symbol, or you could simply um, um, separate them. That's the word I'm looking for. Separate them by a comma. All right, next we're going to talk about the solutions. The solutions are a new vocabulary word that we learned today in today's lesson. But remember, a solution is a 0, is an x value of the x-intercept. So my solutions are going to be -6 and +2. Next is our roots of the equation. Once again, the roots are the solutions, are the zeros, are the x values of the x-intercepts. So it's going to be -6 and +2 once again. Now, we're going to come down here to our linear factors, and I'm going to highlight it, but I'm going to kind of scribble it in. I made it a little bit bigger. Maybe I should come back. Hold on a second. Just so that you can kind of see that I'm scribbling a little bit. Um, I am going to use the -6 and I am going to use the +2 to get my linear factors. However, when I do my linear factors, I need to take the form of x minus one factor, x minus the other factor. So I'm going to use the form x minus one of my factors, and you'll see in the next example that we call it p, and then x minus my second factor, and you'll see in the next example that we call it q. Okay, so this is my form that I'm always going to use. So let me go ahead and put that. Let me grab my gray. I'm just going to go ahead and I want to do x minus one factor, comma, x minus the other factor. All right, so I'm going to do x minus -6. So I'm going to end up having, I'm going to end up having a double negative there with that -6. Remember, when I have a double negative like this, it's going to go ahead and change to a positive. So when I do this, right, minus minus, I'm going to come back in and I'm going to clean up my minus by making it a plus. And so there's my first factor, and then x minus 2. Now, it is very common for you to see them with parentheses around them. So I'm going to go ahead and I'm going to add the parentheses. It's not necessary for the factor, but when we get into writing the equation in factored form, they do have to have the parentheses. All right, I do encourage you to go ahead and pause and try try this. We did go over this in class and I did check it. So I do encourage you to pause it and pause the video, give that one a try, and then ask me in class later if you got it correct, or check with someone in your group. All right, formulating quadratic functions from roots. If the solutions or roots of a quadratic equation are real numbers, p and q, the function of the form, and there it is, y equals a times the quantity x plus p, there's one of my linear factors, x minus q, there's my other linear factor, can be used to describe its related function. The equation can be multiplied to convert to standard form, which is y equals ax squared plus bx plus c. We've already practiced doing this multiplication, and we're going to go ahead and practice that again. So notice from this example right here, we've gone ahead and we've went through the 8 steps on how to go ahead and take the information from the graph and use it to write the equation. Notice that they are having us write it here in factored form first. And then we're going to go from factored form to standard form in the last step. Notice that we are using that form that we learned right here, the a times x minus p times x minus q. We're going to go ahead and we're going to use our roots. We got these roots from our two x-intercepts. That's where our roots came from. And then we do need a third point on the graph. For this one, they did go ahead and use the vertex. But any point could work. We could have used this as a third point. We could have used that as a third point. And then they've just gone through and they've plugged in the point and the roots, and they've gone ahead and solved algebraically for the value of a so that they could write the equation. All right, let's go ahead and practice. So the first thing that we need is we need the roots. We need the roots from this graph. All right, so remember the roots are your x-intercepts, or the x values of your x-intercept. So you're going to come over here and there's our two roots. It looks like -1 and +1. The next thing I need is I need a third point on the graph. Any third point would do. We could go ahead and grab the vertex. It's a pretty standard one to use. I'm going to go ahead and grab it. But you could use any other point. There appears to be one maybe, oh, no, I think on this graph, that would probably be the best one. This is not necessarily the best point to use because it doesn't quite look like it's on there. Let me zoom in. Yeah, no, it's not quite meeting in that corner. It's not quite meeting in the corner. And I can see, remember, they should have on the same side, and it's not meeting in that corner right there. So I think the vertex in this case would be the best third point to use. All right, now we're going to go ahead and we're going to use our formula, y equals a times x minus p, x minus q. All right, I'm going to go ahead and use my colors to help me out. A is the variable that I am going to solve for. That means that I have two numbers that I already know what they are. I know y and I know x. There's x, there's y. So for those ones, I'm going to plug in the x and the y. And then for p and q, I'm going to go ahead. One of them is p, there we go. And then one of them is q. And these are my roots. So let's go ahead and start plugging in. All right, I'm going to plug in a -2 for y because it's right there, right? I had to be careful that I use the right one. I'm going to be solving for a. I'm going to put in a 0 for x, right? I'm going to put in a 0 for x. P is going to be -1, so I'm going to plug in a -1, and then I'm going to come back and I'm going to clean that up. I'm seeing x again. I'm going to go back and use the same x. We're still in the same problem, so we can use the same x. And then lastly, I need q, and that's going to be my +1. All right, all I've done so far is I've gone ahead and I've substituted. That's it. Okay, now I'm going to go ahead and solve algebraically. I'm going to come in and I'm going to clean up my parentheses. 0 minus -1. Remember, minus a minus changes to a plus, so it's 0 plus 1 or 1, and 0 minus 1 is -1. Now I'm going to go ahead and I'm going to multiply 1 times -1. 1 times -1 is -1. And I'm going to move the a to the back because remember, when I have a variable, a letter like a, I want to see the number in front of it. Plus, I don't want to confuse myself. See, it's all multiply right here. I don't want to all of a sudden say a minus 1 and I think it's subtraction when it's really multiplication. So I want to go ahead and do that. To get rid of that multiplication, I'm going to go ahead and divide, giving me a value of a that is +2, -2 divided by +1. All right, it looks like I almost ran out of room. Okay, factored form then. I'm going to come back to my my formula here, and I'm going to go ahead and I'm going to rewrite it. I'm going to use this formula right here. Now the green stuff is going to become those variables. X and Y are going to stay X and Y. So I'm going to start with Y equals. I'm going to put my letter or my number for the variable A. I'm going to keep X and I'm going to put minus 1 X minus 1. I just went ahead and did my P and my Q, and because my P was a minus, it went ahead and did that double minus just like it did here. This is my factored form. Oops, that was crazy. There we go. There we go. Now we're going to go ahead and we're going to take our factored form and we're going to go to standard form. We're going to change it to standard form. Remember, standard form is y equals ax squared plus bx plus c. Factored form means that I need to come over here and I need to do my multiplication. I need to make my box and I need to split it vertically into x plus 1, my first factor, and then I need to split it horizontally, x minus 1, my second factor. These came from my formula right here. These are the two that are going to make my box. This one's going to get distributed after. All right, remember we multiply the left side of the box times the top of the box. So it was x times x, or x squared. Remember, it is a box, so it has the properties of a square or a rectangle. This line would be x times 1 or 1x. This one would be negative 1 times, go up, x, which would be negative 1x. And the last one would be negative 1 times positive 1 or negative 1. The thing that I love about the box is that the like terms will always be across from each other like this, and the box will always tell you what to do, add them together. All right, that would give me x squared. Ooh, 1 plus negative 1 would be 0, so I would just have the beginning and I would have the end. That's all I would have. All right, I have to multiply this by 2 because that was the part of my equation that I left off. So I did this one times this one with the box, but I still have to do the times 2. So I'm going to go ahead and I'm going to distribute that. I'm going to multiply and I'm going to multiply. I think I can just go ahead and zoom out just a bit because I think 2 times x squared would be 2x squared minus 2 times 1 would be 2, and there is my standard form. All right, let's go ahead and try this together one more time with the function that we're given, the graph of the function we're given in example 3a, and then try 3b on your own. I went around and checked them. I'm going to go ahead and put the answers for the factored form and the standard form on there just to see if you can get the problem correct. All right, so remember the first thing you need to do is you need to find the roots. Remember the roots are the x-intercepts. This graph, however, only has one x-intercept. Its only x-intercept appears to be here at negative 3. What is happening here is that you have double roots at negative 3. So we're going to use P and Q to both be negative 3. That's what's going to happen for this one. Our third point, I don't think we can use the vertex for this one because that's our root as well. It looks like the vertex is our root, so we can't use that one. Let's go ahead and for our second one, we could use this point right here. Let's go ahead and use that one right there, which is negative 2, positive 1. Now, could you use this point? Yes. Could you use this point? Sure. Could you use that one? By all means. Any of those would work. Those are the ones that I chose. So just remember, this is X, this is Y, and this one is going to be P and Q. It's going to be both of them. So this one, remember, is going to be P and it's going to be Q. All right, so let's go ahead and let's substitute in. There's our form. And let's just remind ourselves what we're going to substitute in. So we're going to substitute in y, we're going to substitute in x for both x's, and then we're going to substitute in p, and we're going to substitute in q, but they are going to be the same number. Let's go ahead and substitute. So y is positive 1, a we're solving for, x is negative 2, minus negative 3 for p, negative 2 minus negative 3 for P. Because remember, P and Q are the same for this one. Okay, I'm going to go ahead and solve this algebraically. Let's see, this is going to change to a plus and a plus. So negative 2 plus 3 would be positive 1, and it's going to be the same for both of them. I'm going to go ahead and I'm going to multiply 1 times 1 is 1, and I'm going to move the variable a to the end. Now, technically, I do not have to have that 1. It can become invisible, so I'm just going to go ahead and say that a is 1. Okay, a is 1. It can become invisible. So my factored form is minus minus 3 minus minus 3, or I could simply say y equals. I can make the 1 become invisible. And since my two factors are the same, I could write them like this. So I have my 1 becoming invisible. And since my two factors are exactly the same, I can write them once and put a square because they are the same. Remember, we're multiplying them together, right? Just like x times x is x squared, 3x squared times 3x squared is 3x squared. So either one of these is correct, and you can use either one of them for your factored form. Just go ahead and box in the answer. There we go. Now for standard form, I'm going to go ahead and all I need to do is multiply 3x squared, 3x plus 3 times x plus 3, sorry. Hold on, there we go. Let's make the box. We're going to cut it vertically, x plus 3, and we're going to cut it horizontally, x plus 3. Remember, we're multiplying the side of the left side of the box times the top of the box. The left side times the top. The left times the top. The left times the top. Remember, when we get down to these ones, and this one, we're looking all the way out to find where we multiply, what we multiply. So x times x is x squared, 3 times x is 3x, 3 times x is 3x, and 3 times 3 is 9. Remember, we always add these two together because that's what the box tells us to do. And I think that's it. There's a 1 in front, so I'm just going to write my form. Remember, I always start in the upper left corner. This is where I start, and I always end here at the lower right corner. So x squared, I'm going to take the 2 in green, and I'm going to add them together, 6x plus 9 because it is positive. All right, I encourage you on part B to go ahead and pause the video and then go ahead and check your answers. For your factored form, you should have a form that looks like this. There's your factored form. And for your standard form, when you multiply it out, it should look like this. If you have any questions, please make sure that you either ask me or ask someone in your group. That's a 30. There we go. That's a 30. All right, our last and final example is asking us to take the graph of the quadratic function shown, which is f of x, and use the graph to identify the x-intercepts, the zeros, and linear factors of the function and the solutions and roots of its related equation. Then write the equation of the function and the factored and standard forms. All right, I didn't do that. I think I'll go ahead and write the factored form, and then maybe we can practice doing the standard form as well. All right, so let's start with our x-intercepts. There we go. There we go. They appear to be at -1, 0 and +4, 0. Remember, I'm just counting, right? There's my 0. So 1, 2, 3, 4, and this one would be at -1. All right, my zeros, remember, are the x values of those 2 points. So my zeros would be -1 and 4. My solutions are the same, -1 and 4. My roots are the same, -1 and 4. And now my linear factors. Remember my linear factors, oops, there we go, are going to be x minus p and x minus q. Those are going to be my factors. So I'm going to say x minus -1, but I'm going to come back in and I'm going to clean that up. A double minus is going to go to a positive. So there's my first factor, and then x minus 4. Remember, to be in factored form, I'm going to put them in parentheses. So whenever we're talking about factors, I like to put them in parentheses. Here's my factored form. I can already write my, well, no, because I'd have to find A, wouldn't I? I need to know A to find my factor to write my equation. All right, so we're going to need another point. Here we go. I would say that is another point right there. That third point appears to be, let's see, 0, negative, let's see, 1, 2, 3, 4, 5, 6, 7, 8. Oh my goodness, -8. There we go. Those are going to be my x and my y. And here's my p and q, right? Here's my p. Here's my q. Oh no. All right, and to write in my factored form, I'm going to go ahead and I'm going to use this right here. And let's go substitute in. For y, we're going to go ahead and we're going to put in -8. We're solving for a. Change color. There we go. For x, for both x's, we're going to go ahead and put in 0. Okay, that's not bad. And then p, we're going to plug in, what are we plugging in for p, guys? -1, so that's going to go ahead and change. We're plugging in 0 once again. And then for q, we're going to go ahead and plug in 4. All right, let's get this thing solved. All right, -1 minus -1. Well, that's going to go ahead and change to a +1. So that's going to give me 1. And then 0 minus 4 would be -4. Okay, -8. 1 times -4 is -4. And then the a is going to go back behind. Because remember, I don't want to think of that as a minus, that minus as a negative. I want to remember that there's multiplication in there so that I can divide to get rid of it. There we go. 2. A is 2. So in factored form, my equation would be 2 times x plus 1, x minus 4, which would be those two linear factors right here. This is why I like to put the parentheses around them, because then I know they go in right away. They go in exactly into the formula. We could go from there and go into standard form. Let me see. Let me see. I think I have some space and I can do this really quick. I'm going to take my two factors, my two linear factors, and I'm going to come over here and I'm going to cut my box both vertically and horizontally, putting one at the top and then one at the side. X times x is x squared, 1 times x is 1x, negative 4 times x is negative 4x, and negative 4 times 1 is negative 4. We're going to go ahead and add those two together. There we go, giving me x squared, because I always start in the upper left, minus 3x minus 4, because I always end at the bottom. I do have to go ahead and distribute a 2 to that, so I'm going to multiply everybody by a positive 2, giving me a standard form equation of 2x squared minus 6x minus 8. And there are my two equations, factored and standard form. I'll just put an F here and an S here.